So coming to the microservice architecture, second unit point of view. Moving to the second unit is an so up to now we are completed overview of interprocess communication, microservice, remote procedure invocation pattern, asynchronous messaging pattern. Now we are going to think about the asynchronous messaging to improve the availability, transaction management in microservice architecture, coordinating circuits, handling the lock isolation, overorder service and overorder circuits. So coming to the asynchronous messages to improve availability. Multiple calls to many such a single responsibility independent pieces through we can have a synchronous request and response call when the request is expect immediately response. Integration patterns based on the events asynchronous messaging provide the minimum scalability and resiliency. The system ability to anticipate and handle the failures in its own services or an external dependencies ensuring the continued operation and minimizing distribution. So coming to the here, what are the techniques we are using under the asynchronous communication? To build a scalable architecture, we need an event-driven and asynchronous integration between microservice or architecture. There are a lot of options for an asynchronous integration. Some of them widely used are the Kafka, RabbitMQ, Google Pub Sub, and then Amazon services, ActiveMQ, Azure services. These are all will be comes under for the asynchronous innovation pattern purpose. So first of all, we need to see about the what is an Kafka. Kafka is the most popular open source distributed publish and subscribe streaming platform that can handle million of messages per minute. The key capabilities of Kafka are the publish and subscribe the stream of records and store the stream of records in a fault tolerant way and process streaming of a record as they occur. That these features make a Kafka is a natural choice for a number of use cases which are listed here. The key component of Kafka architecture are the topic patterns and then broker, procedure, consumer, zookeeper. The core API in a Kafka will be going to include the procedure AI will follow an application to publish a stream of records to one or more Kafka topics. So see the example here, I'm taken as one of the Kafka broker means nothing but an here one of the Kafka cluster is an maintaining here. Cluster is nothing but an may group of members will be joined will be in a same sector will be called as an cluster. Here I'm going to maintaining the sector will be comes under the Kafka sector. So here what I'm going to discussing about the how Kafka will going to maintaining the procedure and then producer and then consumer. Here the producer want to push the request and then consumer want to pull the response whatever. Here the total everything this producer and then consumer Kafka cluster everything will be maintaining by the zookeeper. One of the main third party will going to maintaining here that is an zookeeper cluster will going to the maintaining here. Then coming to the next architecture here we having the broker 1, broker 2, broker 3 like an Kafka. Here we divided into the some other different form. The procedure will going to the producer will going to generating a request to then forwarding that request to the Kafka cluster. The Kafka cluster will be divided into the different types of the patterns. So each pattern will going to provide a service to the producer. Then whatever the producer generated request will be again forwarding to the consumers. And next, coming to the Kafka is one of the distributed replicated commit log. Kafka does not have the concept of the queue, which may be straight at first. Give at the primary using for the messaging system. Queues have been synonymous with messaging the system for a long time. Let's break it down. Distributed replicated commit log a bit. Distributed Kafka is deployed as a cluster of nodes for both fault tolerance and then scale. Replicated because the messages are usually replicated across the multiple nodes. Commit log because the messages are stored in the partition. And next, RabbitMQ. The core idea in the messaging of a model is in RabbitMQ is that the producer never send any message directly to an queue. Actually, the quite often the producer doesn't even know the message will be delivered to any queue at all. Instead of producer, they can only send a message to an exchange. And exchanging is a very simple thing. On one side receives a message from producer and other side it pushes them to the queue. The exchange we must know exactly what we do in the messages it reads. Should it appended to particular queue? Should it be appended to many queues or should it discarded? These rules are defined by the exchange type and direct topics we can discuss. Then coming to the here, the produce. I mean, next technique we are using is then the producer how will going to sending a response to the consumer is then the broker will maintaining the exchanging and binding and then queues here directly and then topic and then fan out. With previous Kafka, the request is directly hand over to the queue, but here we are not directly handovering to the queue. Our next coming next slide will be so next one is an Google Cloud Art Pub Art Hub. Now these days we are using the Google Cloud. We want to save our data. Every particular client will going to using their Google Cloud to store their data. Fully managed real-time managing services that allows you to send and receive messages between independent applications. We can leverage the cloud means flexibility to decouple the systems component hosted to the Google Cloud platform. And next coming to the here, publisher will going to sending a message directly to the topic. The subscriber will going to sending an acknowledgement is that he is a subscriber or not, and then returning back a message. And ActiveMQ is one more technique we are using. ActiveMQ is a Java-based open source project developed by Apache Software Foundation. ActiveMQ makes use the Java Message Services JMS API, which defines a standard for software to use, creating, sending, receiving the messages. ActiveMQ sends the messages between client application producer, which can create the message and submit them for a delivery, and consumers, which receive the process and messages. The ActiveMQ broker routes each message through one of type of destination, a queue where it is awaits delivery to a single consumer in a messaging the domain called point to point, or a topic to be delivered to the multiple consumers that describe it to the topic. And next here, see the architecture here, point to point, another one is an queue form will be there. Then between the sender will going to receiving the messages and then sending back to the consumer. Transaction management in a microservice architecture. Based always the transaction will be depending on the asset properties, that is an atomicity, consistency, isolation, durability. Atomicity, all operations are executed successfully or everything fails together. Consistency, the data in the database keep our state as stated by its rules, such as say integrity will be providing here. Isolation will be transaction how successfully will be happened in between client and the consumer. And next one is in durability. The transaction is committed, the changes are stored durably, will be considered durability. So here phase one, the coordinator want to try to either make the payment. He is ready to commit means he then make a payment. Not ready to commit means block the seat, and then he is ready to commit yes or no based on the allocating the seat. Like an coordinator, phase 2 are also committing the either providing the positive or negative acknowledgement. Based on that one, the committing will go into the happening. And next, coordinating saga. Saga is the almost go to the solution when it is comes to the distributed transaction. Understanding how effectively handle the transaction to the span multiple services becomes the crucial to clarify the fundamental principles of the sagas, but also provide the practical insight in their strategic application, ensuring the robust error-free interaction within a service. The needed of the distributed transaction in a microservice architecture is that verify the consumer customer is placed on order and verify the order details and authorize the customer credit card and create an order in a database. So this is the architecture I'm given to the previous slide. And next coming to the using the saga pattern, how we are going to maintaining the data consistency. Sagas are the mechanism to maintain the data consistency in microservice architecture without having the distributed transaction. Saga is each system command that needs to be update the data in a multiple services. Saga is a sequence of the local transaction. Each local transaction update the data within a single service using the familiar ACID transaction framework and libraries. The system operation initiates the first step of the Saga, the completion of the local transaction trigger execution of the next local transaction. An important benefit of the asynchronous messaging is that ensure the all steps for the Saga are to be executed even if one or more Sagas participations are temporarily available. Saga differs the asset transaction couple of important ways. The lack of isolation property and asset transaction. An example of the Saga is in creating an order. Next one is in see here. For best example, we can take as a Saga order service and consumer service, kitchen service, and accounting service. Each everything will going to maintaining their independent modules, needs not depending on any other module. So here and they are dividing into the order service, consumer service, consent service, accounting service, and then we are divided into the different sections.